recording. Okay, now we want to do all these nice things that we were doing before, and I want to start from a blank editor, okay? And then we will polish the program at the end. Blank piece of thingy, all right? I will call it coso.cpp, the thing. So now, I start. Normally, like when you start with a blank editor, you have this problem. Where do I start? Where do I start? You start always from something which is simple and you can do nicely. Like, what do you expect that there will be in this funky hierarchy or in funky program that we can do straightforwardly and maybe might strengthen your awareness of robotics? Well, simplistic algebra, simplistic data types that manage 2D points and 2D transformations, right? Does it make sense? And we will override the operators in a way that they make sense. No? That if you take a transform and you multiply it by another transform, then the result will be the composition of the two transforms, right? Then we start, I just write everything in a CPP, and then I will polish it, okay? Struct point 2D. What do I have in a point 2D? Float x, float y. Then it's also wise to add a constructor. B, just so x, y. No, don't do it. Everything will be public, the code. Don't copy the thing. I mean, it's better that you guide me. Okay, then I want to note a y. Note, do I want to use the initializer list? Or do I want to assign it normally? If I want, note that this x is different from this x. That's an underscore afterwards, okay? No, no, you can't use it in the initializer list. I'm not sure you can use it. Bah, let's see. Never done. Well, x, y, y. One more parenthesis. I'm done. I can also say that this is equal to 0 and this is equal to 0, so I gain the default constructor. Okay? Fine? Then do we need the copy constructor? No, it's perfectly fine, because the assignment operator and the copy constructor will just copy all the field members, so I don't need anything else. Then I think we might want to have a multiplication by a scalar and a sum of points. To D. Make sense? That's it. We have the plus, we do the minus. We might want to have the operator star multiplication by a scalar. So to make a vector larger. Ah? Non t'ho sentito, qualcuno parlò? No. Is it fine? Yes. Then, given that we are well behaved, Nah, just without arguments. We just test it. I wrote a class which is that big, but I just want to test it immediately. It's a good behavior. Let me, aha. Sto cercando un generatore. I'm looking for a generator for the electricity for the next time. We need a print operator, right? Oh, 2D. And then I just redefine the outstream operator so that I can print a point. And so I need to include the input-output stream library. I mean, I would type much faster if I would have a normal keyboard. Now I have it drum out this thing. I would delete much less. We compile straight away with G++, no mercy. Minus O, coso. Yes, I want to save it. Error, unqualified, you're right. Float X and Y. This is the first error. Error, class point2D have no number, of course, because it wasn't defined. Return point2D has not, I knew it. Let's try again. Oh, good. Well. Then in the main, we declare a point to D. Uno, 1, 1. Point to D. Point to D. 2. 2 minus 2. Come on. Let's print 1 minus 2. And 1 plus 2. And 1 or 2 times 0.5. So do we test all operators? Do you see what happens and the magic here? Because it starts evaluating this expression. It calls this operator. It evaluates this expression, but in order to evaluate this expression, it has to resolve the expression 1 minus 1, 2. It calls the minus operator. It returns back a new object, which is the difference between 1 and 2. And then it can keep on evaluating the stream operator, and then it prints the object. But that's what will happen. What do you expect to happen? Nothing spectacular. Coso. 1 minus 1, 3. 3 minus 1 meno 2 is correct. Yes. And the other one is correct. Okay, fine. We're content. Small piece of code. Immediately tested. Then it's time for us to do the transforms. Pose 2D. Struct. What we will have in the pose 2D? We will have a point 2D, which represents the translation. And we will have an angle. We could have a rotation matrix, but I just put in an angle, it's easier. Fine. Const point 2D ampersand T. Const. Oh. point, no, const float, Why did you use const float at %? It's my habit. When I have a constant parameter, I tend to always put a reference with const inside. No, there's no reason. I could just like put a float, because if I put a float, I don't lose anything, in a sense that if I put a if I put a float this way, the float will be copied on the stack, and even if I mess up with the float in the function, nothing will happen. I will create a copy of the variable. Happy? I have all what I need, right? Might also want to have a pose 2D with x, y, theta if I want, no? Just to have more sugar. I'm calling the constructor of the translation, passing the parameter x and y, or x underscore and y underscore, just not to mess it up. Clear? Yes? Very good. Then what else? What else? Obviously, we want to compose positions, no? Or we might want to multiply a pose by a transform matrix. Okay? You multiply a point by a transform. If you multiply a point by a transform, the point is multiplied by the rotation matrix of theta, and then is added to the translation of the transform. P. Cosinus, sinus, yes? Do? Ah, c'è ragione. Sorry. Yeah. Return. S times P dot x, no, C times P dot x plus S minus S times P dot y. Make sense? This is the first line of the point, and then the second one will be S plus C. Make sense? Easy peasy. And also, another thing that we might want to do is the operator, the multiplication by another transform. So that means that I calculate the transform. I calculate a new transform that is the previous one times the next. So the rotation matrix will be the product of the rotation matrices, and the translation vector will be the translation vector of the first plus the rotation matrix of the second, multiplied by the translation vector of the plus the rotation matrix of the first multiplied by the translation vector of the second. Did you do the transform with De Luca? Ah.
Not yet. Watching videos.
Okay. Okay, if I have a rotation matrix and a translation vector, when I say rotation matrix, do you agree with me what it is? Yes, it's an orthonormal matrix, no? If I have R1 times T1, which multiplies R2 and T2. This is the translation vector and the rotation matrix. What is the result? Is R1 times R2, and here I have T1 plus R1 times T2. This is the result, the definition of the product of two transforms. Just like write down a homogeneous matrix, which is a 4x4 matrix, which has a rotation matrix in the first 2x2 in the first elements, and a translation vector in the second, and then 0, 0, 1 on the bottom. You take two, you do the product, and you verify that this is correct. Okay, and so you can also verify that we can also calculate the inverse, but yeah, the inverse is easy. I will not do it, I wait for the Luca, otherwise I mess up your thing. So point to D, we said pose to D. This is a, write it as a comment. Pose to D. Operator star const pose to D, ampersand order. What will we do? Pose to D. To D. The translation vector happens to be exactly equal to the start this, oh, bye, times, if you look at this definition here, the translation of the part of the composed transformation is equal to the translation which is applied to the first transform, which is exactly what we have written here. So I will simply use the operator star. There are many ways of calling operator star. I could also do this. Operator star. But by what? What should I multiply? Other dot. I'm calling the multiplication. You can call it explicitly an operator. With operators, blah, blah, you can call explicitly the operator. This is the translation part, and the angle will be just the sum of the angles. Make sense? That's it. Let's see what happens. I have also to, to write the operator blah, blah, blah for the pose. Why did you use pose translation? Because translation is a vector 2D which is contained in a pose. It defines the operator start, the operator this, but there was a mistake. I have to return the output stream that I've modified, otherwise it breaks. Yes, sinus, I don't know sinus. Oh, you don't know sinus. I have to include the math library. Okay. Well, this will work as before, I can imagine, because I didn't yet instantiate transforms. So, pose to D, T1, 0, 0, 1, 1, 0, pose to D, T2, 1, 0, pi, and pi means pi half, right? 90 degrees, 2, and then we want to print the composition between these two. Okay, so we want to let's try, well, we want to print T1 times T2. T1 T2 and T1 times T2. And also T1 times T2 multiplied by 1. Because this is the point, you know, I'm composing a transform and then applying it to a point. Coso. Well, so like this is a bad thing for me because when I wrote the when I wrote the operator stampa print, I put an end line, so it's unaesthetic, unaesthetical. Okay, so I have an end line ending up somewhere else. Here, basta. Okay, better. Coso, these are all the fantastic points. This is the first transform, this is the second transform. Then here I have a 0, 0, 0. It's really horrible, right? Isn't it? Means that I made a mistake. Because if I multiply 1, 1, 0 by 1, 0, blah, 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 I shouldn't get this value. Should I? Yes? No? No. No. I shouldn't, because I'm basically operating a shift. This is the base transform. This is the first transform. This is the second transform. So here I would expect 2, 1, and 1, 5, 7, 8, 0, 0, 0, 0. So I made a mistake in the multiplication. Yes. And why? Okay, better. Eccolo.
When we write operator star in close to the operator star,
okay,
it takes.
I make it nicer. Okay, and
I don't understand which the two arguments are.
Oh, other translation. What is the type of translation? It's a point. Okay, so which function operator star am I calling? This.
And on which is he acting?
On self. Okay. I'm inside myself. I'm inside my own class. Okay? If I want to make it nicer, I could do this. I create a reference to myself, and then I could simply do, Jesus. I could simply do if you want to see it in another way. Sorry. Give me a keyboard, a human one. Okay. No? No. Passing, right. Const post 2d ampersand. Yes. Yeah. Why the compiler complains? Now it says passing const post 2d as this argument discards qualifiers because I declare a const reference to myself, and I'm invoking a function, in particular this function over here, which is non-const, where even if it doesn't change the class, I didn't tell to the function, to the system, that it's not changing the class. And so it complains. So I could fix it by saying const here. And then it will like it. And also here, const. This means that I'm not changing the invocation object. Okay, now it will hopefully work. No, yes. I have to put const all over, no? No match for function operator plus. Right. Const. Const. Without ending. Const. Or you can delete all the constant, everything will work anyway, right? But, okay, now we have our presumably nice algebra of points. Okay, we can do transform, we can write funky expressions, everything as if it was in MATLAB, so to say. Okay? Guys, did I kill you with the transform or not? Yes or no? Okay, well, a parenthesis on the transform. What is a transform? A transform is an isometry in particular. An isometry consists in a rotation and a translation. Okay? Agreed? A rotation that could happen either in 2D or in 3D. Fine with that? Yes. Now, if you want to apply a transform, which is including an isometry, which includes a translation and a rotation, translation and a rotation, okay? What do you have to do algebraically? Well, a rotation can be expressed by a basis in a reference system, like by two axes, two vectors, which are orthogonal to each other, which have unit norm, or three vectors in 3D, or n vectors in Rn. But anyway, in 2D, basically this angle, the angle between the first of the axes is the theta. What is this vector if this angle is theta? It's cosinus of theta, sinus of theta. This vector is the orthogonal to this. So minus sinus cosinus. And this identifies a basis. Now if I have a point and I multiply a pair of coordinates and I multiply by this basis, this is equivalent to calculate to express the point in the global frame that is applied to this basis. So I have to take this vector here and multiply it by x, and I have to take this vector here multiplied by y, and then I compose the two things and I get the point in the word frame. Geometry 1, no? Basis. What do I do with the translation? The translation is a shift. No, it's a vector that goes from the origin to the new origin. And this explains what I was writing here. Like in terms of, where was it? No, I deleted the spiegone. No? Yes, no, I didn't delete it. Now, this is clear. So if I have to apply a transform to a point, I rotate it by r and I translate it by t, where t is the translation vector. Okay. Now, it might be that if I have a transform and another transform and another transform, this is classical transform chain, what do I do? Well, I have to take two transforms and construct them together. Okay? Like, now, rudely saying, what happens to the two transforms? The angles in the plane in 3D is a little bit different. But in the plane, the orientation is just the sum of the orientations. Do you agree with me? Very good. What happens if I have to the translation part of the result? Well, the translation part of the result is nothing else than a vector, than a point. And you transform the translation as if it was a point. We just have said how to transform a point, which is this stuff over here. Okay? So in order to calculate the composition of transform, what do? I apply the transform to the translational part, which is a point, and I sum up the angles, because if I have a rotation of 10 degrees and then another rotation of 10 degrees, the chain of transform will be 10 and 10, which makes 20. Clear? Very good. Here is implemented. All right. Okay. We are done with our algebra things, and let's start constructing the word. Qualcuno scappa. Okay. Look at the rudeness. I just write struct. I ignore all public, private, whatsoever. All right. What do I need? For sure, I need a bunch of cells that are adequate to store an image, right? I will just do a matrix for storing this canvas. I like char, come on. And I call it grid. This is the pointer. I need a number of rows and a number of columns. Make sense? I also need a float that tells me the resolution, because I said that a word, no, a thing in the word as a cell as a dimension. And also, like, I might imagine that I want to calculate I want to go from cell to word and from word to cells. So I might want to store the inverse of the resolution in order to avoid a division which might be expensive all the time. Okay? Do I need else? Anything else? Oh yeah, I need plenty of things, but let's start with this. Okay, then next thing I want to do, now forgive me, because now I will have to include OpenCV. So ignore what I'm doing for now, because I will have to implement a function. That reads this stuff from an image. Okay? Okay, I've done this function already, obviously. Oh, I've been consistent. I'm incredibly consistent. It's amazing. Ignore this part, right? What you can imagine is that this function will allocate a grid which has a size which is appropriate to contain the image, which is a grayscale image, so every byte represents a pixel, and it will populate the rows, it will populate the columns, okay? And what it does internally is my own business, okay? Int size, come on. And then I'm sure that I need to link something to include OpenCV, yes. Coso. Of course, I'm using OpenCV, so I will have to link to include the OpenCV library. Okay? Let's see if it compiles, but it won't. You int 8t. Okay. Sure. Better? You're getting horrible things. What does it mean? Undefined reference. What does it mean? That I told him, hey, the header file of OpenCV are here. But I didn't tell him which are the libraries of OpenCV. Okay? So I will have to tell him the library. And I don't even know where are the libraries of OpenCV. But or I could use a CMake. So let's build a CMake in here. Okay, now I have written the CMake, obviously, because I never remember. The CMakes are never written, are always copied and extended. Okay, this is the basic rule of the CMake. Okay, what I do is not relevant, I think. O3, okay, this is not relevant. I wanted to be fast. Include directories, we don't need eigen here. The only thing we need, we also don't need this stuff. So CMake minimum required a super obsolete version, the name of the project, and then we have to use the funny thing, find package OpenCV, required. You have to say include directories OpenCV, include dirs, and then add executable with all the binaries that are required for that executable, which is now called COSO. Okay? So this will be COSO. And it depends on COSO CPP. Clear? This is the target. And what are the libraries that we have to link on COSO? We have to say COSO has to link all the library the expansion of the variable OpenCV libs, which is populated by the find package. Okay? So now we can start compiling proper. I'm brutal. Oh. Qua. Let me a little bit well behaved, right? I just put a build directory in here. CD build. COSO is built. Very good. Now I can load an image. Fine? I mean, of course, this part I did not explain to you, but if you want to have a look, I'm using the function imread of OpenCV that returns me a matrix. Then I take this matrix and I convert it to a grayscale image, because I said that my image should be a gray image. And I write this image into a variable of OpenCV, which is called display image, that I will be using for doing my own things. Then there is a variable that I call grid, and I do the allocation of I calculate the size. This is the size data member as the number of rows and number of columns of the image that I have just read. I allocate the grid. I just copy the fields, and this is the thing I like. Then I do a brutal mem copy of the whole data section of the image into the grid pointer. This is equivalent to do for int e equals 0, e smaller than size, plus plus I, grid dot I equals dot data dot I. This is equivalent to that for those that are not. No? Clear? Very good. I access the raw matrix batch. Fine. Let's see if it works. But to see if it works, I have to go to the main. Word is afterwards. And shall I add also another function that I call show to display the words? That makes sense, right? To display the image that I just loaded. Otherwise, I don't know what's going on. I don't remember all the functions of OpenCV. What was it? In show. But before showing the image, there will be things that will happen afterwards. But before showing the image, I want to do another thing. I'm going to use this OpenCV image over here, right, as a canvas, as a place that I will use for drawing all my objects and everything. So the very first thing that I do is that I copy the background onto the image, and then in the later extension of this show function, here I will do stuff. Because first I write the background. And then on top of the background, I'm going to make pixels darker depending on where the robot is. Where is the background? I store the background where? In grid. So I do this the other way around. Display image, no, already copied. And also I need to get some argument from the command line. So int argc char star v. Are we set with those? I think we don't need this stuff anymore. Oh, what did I do? No. What did I do? I think larger terminal. I think we don't need this stuff anymore, right? Or I keep it because I'm not sure that it works. How do I access the first parameter of the command line? Well, argv of 1. This is another function that serves me to pause the system until I press a key, otherwise I don't see any. Show. Basta. So, argv of 1 allows me to access the first line of the command line, in case you have never used argv. If you did operating system, no, I beat you if you don't know what it means. Oh, right. You don't know this because I have to say a string, right? I hope so. Load from image. Okay, good. I know why this, because I'm not compiling in the build directory, I'm compiling still with the old command line. Make -c build. No, build. Better. Compiling. Yes? Oh, let's see. Coso. Test data. Oh, I have the image. I press a key, the image is gone. The program is terminated. So far, so good. But now now the thing starts to become funny, right? Because now I have to start to putting objects in the word, to put the robot, and to do the collision check. Are you fit? Do you think we will manage by 6? Let's see. Another thing that I would like to put in my word is the function collides. I want to put, I want to extend my point to D with another point, which is a point made of integers, because I might need it for the coordinates of my map. Okay? Let me call it pointer to D int point to D. I will call it int point to D, that instead of having float, I copied the point to D. I just query replace point to D with int point to D, and I have another class. And instead of being x and y, there will be int x and y. So every occurrence of float into this class will become an int. Fine? So far, so good. I have another operator. Then what I'm sure I will need in my word are two functions from indices of the grid to the word, and from word to indices of the grid. Do you agree with me? Because in order to put objects, the objects live in a continuous word made of floats, but then I have to discretize them. And if every cell is 5 centimeters, right? Where every cell is big resolution by resolution, where would be the object which is in coordinates 1, 1? At pixel 20, 20. Because in 1 meter there are 20 pixels. Okay? So I have to multiply by the inverse resolution. So int point grid. I have to divide it by the resolution, no? And word to grid returns me a point from the word to the indices of the grid and also the vice versa. Make sense? Safe programming. I hope you're seeing one thing. You're seeing that I'm writing a very small snippet of code every time, and I'm testing it immediately. This is of utmost importance. Because I always, like in this way, I limit the mess. And the dumbest the piece of code, the easiest it is to make errors, like the return of before. What will be the other function that I will write? Point. Grid to word. Int. Point. Point. P per res. Res. So I go from one to the other. Like? Easy, peasy. Keeping it simple also at API level. API means the functions. Okay? And I believe that the word might need a constructor. What do you think? I have a plethora of variables which are not initialized. It's not elegant. No, not nice. You can also initialize the things this way. Works. Just. And then I did these fantastic two functions. I'm really willing to use them. Int point, did I write the operator for int point? No, I didn't. Int point to d. Never without, right? We show point 20 point p1 2010 int point p2 equals world to grid vw dot word to grid of p1 ep integer point 1, and then we do the opposite. P2 word to grid grid to word. P1 yeah, you're right. 2D. Why do you put 2D, Giorgio? Because we will play also with 3D at the same time. See, yeah, I'm doing stuff, but I'm printing nothing, and I also didn't put the commas. The teacher at the elementary school was also telling me, put the commas, put the points. Never listened. P1, P2, P1, P1, handle. P2, P3, no, EP1, P1, P1, and P2. P2. Let's see what happens. Oh, no. int point 2D, yes, int point 2D, 2D, 2D. No. What destroys you? Grid 2 word, IP2. Tells me int point. Eh? Ah, yes. Haha. Eh? No, V è minuscolo. Oh, grid. Oh, Madonna, sono stato così terribile. Sorry. Oh, so inconsistent. I mean, the drama is that I'm so not common. For me, it's not so not common to make these mistakes because I normally have a keyboard. That then it's hard to. Ok. Huh? What did I? Oh, ancora. Point, correct, point 2D. I'm persisting, 2D. Come on. Oh. Okay. Okay. 2010 maps to 400, 200, that maps back to 2010. So I'm able to go forth and back. Now I'm able to put objects one on top of the other, right? Because I can compose transforms. Okay. Then let's have some fun. Let's write a function which we call collides. What is the function collide doing? Let's write function for accessing a cell based on a point. Char ampersand at int point 2D const p. That returns the point, in the grid, the character which is located in the 2D discrete coordinates of P. Okay? Let's say X is the rows, Y is the columns. Because this also gives me a proper reference system with the Z which pops up. So when you see the map, this is the direction of the X, this is the direction of the Y, so that the Z comes out. Positive Z means that the robot is more or less floating here. Okay? Turn grid at calls times p.x plus p.y. Fine. Let's also write a const version of it so that I can, yes. No. I write it this way. And I also I teach you another keyword, inline. What does it mean, inline? Inline means that the compiler will not try to produce code for this function, rather it will expand the code at every function call. Because when the functions are so small, calling a function might be bad, because you have to generate to fill the stack and so on and so forth, but also because this prevents the optimizing pass of the compiler, which is something brutal, that operates perfectly if it finds a very nice stream of instruction without branches. If this is complied, you really get the beast out of the machine. Okay? Clear? Okay, I have an add function. Does it make sense to write also a function which we call inside, which is true if the point is inside? Because I might also go off the grid, right? When is the point inside? I have to be positive, greater than 0, because and rows y smaller than calls, and then inline has to be first. Okay, now let's write a function, compile. Be well behaved, Giorgio. And let's write a function inside collides bool that returns true if the integer point that I'm passing to this function is either outside the boundary or it is closer than a certain distance r from a pixel in the map who is darker than 127. So this point will have to scan a circle of radius, centered in the point that I'm giving, and check if in this circle there is a point which is darker than 127. Okay? Const int how would you do it?
First condition is px greater than loss and py greater than false.
Mm-hmm.
And
And then you will have to scan a circle.
yes.
But what happens if the point is closer to the border than radius? This is good. This is clear, the first condition. But what happens if I am a robot and here the word ends? Now here there is the Mordor Sea. No? And I am there. But yes.
Like physically or?
Yeah, in the simulation. Physically, it might fit because if there is not a wall, okay, but we take it. If not p dot p true. This is okay, no? Equals minus radius. Smaller or equal of to radius plus r. Int point 2d, yes. D of R and C. So here I'm scanning a square, right? And I have a point, p test, which is the points, the cells that I'm testing, which are in a square, which is centered in the point P, going from minus. But if I want to do the check of a circle, I could simply do if I have the operator star, right, for the int point. I copied it by stupidity. Yes, I have the operator star. Great. I could simply check when is a aiuto, lost here. If int point offset equals, that is equal to R and C. This is the offset within the circle, right? If offset times offset, radius by, so xy times xy, like I'm painting a circle. This is the distance from the origin, the square distance from the origin of a point. Okay? So if the square distance from the origin of a point is smaller than the square radius, then this means that I'm inside the circle. R2 times R.
So basically, I'm scribing a square inside the circle.
Exactly. You're sweeping the square inside the circle, and you are ignoring what is not in the circle, no? Continue. Because it means I am outside. And then this means that I have a concrete point if not inside of p-test. Just make it this way so that I don't even need to check the cells. If not inside of p-test, return false. So the robot will, there's an imaginary wall all around my word. And then the final condition, return at p-test smaller, collides, smaller than 127. We like? This is a function that handles the collisions. It scans all the points in a grid, in a circle centered in R and C, and if this happens, everything is. Yes?
F2 shouldn't be radius per radius.
Sì. Yes.
And also there's an endpoint to the.
Yeah, of course. Candidate, blah, 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 blah. What don't you know? What don't you know? Oh, Jesus. Int point is not derived from complex. R2, maybe? Oh. Off. Maybe I'm stimulating some library function. No? You don't like it? Oh, what have I done? Let me check post2d. Where is the int point definition? Here. Oh, you know it. Haha. If I want to implement the dot product, this wasn't implemented. I implemented only the product by a scalar for a point, not the dot product. Int operator star const in point. Oh. Const other return x times x times other dot x plus y times other dot y. Correct? Okay. Fine. We are there. Almost. Not almost. I think, guys, I mean, next time we will continue, like, I will finish at 6. Next time we will continue this exercise, this episode, from the lecture hall, because you asked me to have more than one day off between the lesson and the exercises. Okay, so if at a certain point I won't manage to finish it at this pace, in this time, by 6. So next round, like on Thursday, we will, in case I will not finish now, we will finish that day. So there will not be an exercise, presumably. I will be there babbling, and we will finish, because I'm looking at the time and I don't know if we will manage. But am I losing you, or are you on track? Are you understanding nicely? I love it. Thank you. Okay, then, but we continue until 6, right? No, it's not that we calm the dolls. Non pettiniamo le bambole, come si dice a Roma. North throw coriander. All right, this compiles and makes, I think it's fine, because inside there's a proper condition. Let's check, right? I said I don't write anything without checking. So we check. w.rows. Oh. C, C, plus plus C. I should have selected a smaller image, but that's what I had. And we try a collide, like we sweep over the whole matrix. What we expect is that in the first line, we will get all collides, because it's I give it a radius of 10, and then after line 5, I expect it starts behaving, and then when it starts hitting the gray cells, it will tell me collides, okay? And I will print collide, collide, collide every time I collide. Collide. If collides, W collide, int point to T, to D, R, C, comma, radius 10, 10. 10 is half a meter. So we have a robot of 1 meter. It's like a big beast. 10. Oh, collides. Oh. Me collide, me collide. Me collide a lot in the row 70. It's too long. Let's row 70. Row 70. It's too big. So, ouch. Test data. I create a smaller image, right? Tools. Tools, Windows, Toolbox. Toolbox. Go here. Clipping object. Oh, no, eh? You don't like it? Ah, this one. Yes. Better. Makes more sense. File. Export as. Cappero. Clippato. Export. Better, no? Oh, this got changed. Dai. Okay. Clippato, no? Chip. Okay, which is consistent with my rudeness. Okay, let's see. Collides too much. What do you think? Collides for the whole grid? Or? No? Collides too much to me. So 20. Clip. It's important also to debug, right? It's human. Okay, I'm printing 20 lines and I see that I'm colliding all the time. I know it. Collide function. So I exactly exactly. So if not inside, if at pit test is smaller than 127, return false. Otherwise, return true. Exactly. And when do I return true? I mean, like a little bit of cosmesis. Parenthesis, parenthesis. Yeah. False. Much better. Before I was like talking and babbling and I forgot the termination condition. Like the game is that while you scan the circle, if I'm outside of the circle, you do nothing. Then you get that point. If you're not inside, well, you're not inside and you return false. If there is one point which is smaller than 127, then return false, which means that there's an obstacle. Is smaller than other, and otherwise you return false, which means there's no collision. I was forgetting the return false. And given that I'm not compiling with warnings, which sucks, the compiler says, oh, good, go ahead. No, and it returns me the last variable in the stack. Oh, I like it. Okay. Right, because maybe now I really seriously clipped it all, because I started from row 20, and I want to scan it all. No, and now I never collide. Oh, Jesus. It's horrible.
There is no improvement.
Huh?
Shouldn't be returned true if fitness at the beginning.
Oh, yes?
And also,
No, because if I manage to scan the whole circle, no, the whole thing, and I never found a dark cell, then I have to return false. Yeah. I mean, guys, it's human. Okay, me collide. Let's see if it makes sense. Now it collides everywhere or not. Oh, how many collisions do you have? Let me check the number of collisions divided so in the ratio of the size, which is probably giving me more clear insights. And no. We don't write this. Oh, anche. No? Num collisions. Where do you complain? These sides. W dot size. Basically, it reports, this was a good test. It reports every collision. You see, one simple function is giving me so much headache. A little bit because I'm tired, but also because W rows, W calls, this is okay. Let's see if I made some mistake. Where could I have made a mistake? Very first thing is the at function. I could have made mistakes in the at function, right? But it doesn't look like. I do memcopy.
Did we define the size of the radius?
Radius, what was it? 10. It's a float or int. It's an int radius. R2 is radius times radius. R between minus radius and blah 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 blah.
Should we return false if test is less than 127? Like, if it's less than 127, it's white, right?
If it's less, no, it's 255 is white.
Let's go.
Okay.
I didn't understand the
If it's not inside, if not, it means that I am outside the grid.
Ah, okay, outside the grid.
Offset. I mean, I could have made a mistake in offset by offset. Where were the functions that I didn't test? Question. Int point, or somewhere here. Int point. X times other plus. No, this is consistent, right? Well, you know what? We can do some. What do I do in these cases? I mean, that's one system call that you can use, which is called exit 0. And this is what I do when I want to debug a function. Exit 0 terminates the program, so that then, without any mercy, I will print what are the coordinates of the circle that is going to be painted. So I would start from to check collisions in the center to see if the circle that I'm exploring is really a circle. Okay, I will look the coordinates of this 10 by 10 circle. Yeah, the very first thing that makes me doing it. So int point to the center, which is equal to w.rows divided by 2, comma, w.calls divided by 2. Make sense? Yes. And then w.collides, w.rows, center, and I instrument the collides to print me every possible crap. So only if it is a valid thing. If not, it's inside. This is here. At calls grid times. I want also to print the value of this element. I have to cast it as integer, otherwise it will print me the ASCII character. Ah, io ho fatto il cast dello stream, sì. Buono. Ok. Ok, vediamo un po' che succede. Becco dei valori che sono uguali a meno 1. Meno 1, meno 10. Ma che roba è questa? Ah, la so, lo sai qual è il problema? Che è un unsigned char questa roba, non è un char. The big problem is that I forgot that the images are unsigned char. So I have all the range between minus 127 to plus 127. That was the mistake. Okay? So like that's why I use normally uint 8t. I hate the word char int, no? It's like uint 8t means you have an integer which is unsigned and it's 8 bits. And it's the same on every architecture. That was the mistake. I have to declare the grid as unsigned char. So now, allow me to do a query replace, Alt-X replace string char with uint 8t. It's blessed. It's a char. It's an unsigned char, but it's a standard. It's the same on all architecture. I did a query replace, right? But CMake, but OpenCV expects to have a char, right? So you int T star stuff. Ok. Ancora. Oh. Now it's satisfied. The value is always 255. Do you notice that? Cioè, it's only reading at 255. So, what might have happened? What might have happened? Might have happened that this mem copy has failed, right? Because here I'm copying into the grid the image data. And here, in the display, I'm doing the opposite copy. Maybe memcopy does the other way, man to memcopy. Destination, no, it's correct. It's not like OpenCV. Okay, how can it display that image? I'm scanning that image. 255 is white, it's perfect. Sorry, 255 was correct. I didn't report any collision. 200, because in the middle of the image is white, right? No. In the middle here, presumably, is white. So I could just like make a bigger circle and to see if I get a collision. No? Make sense? So let me remove the test. I mean, you see how tricky it was to debug this thing? The bug wasn't where you thought it was. It was in the data type. And only by visualizing you realize, oh, but minus, it can't be minus. This is a positive number. All right? Now I killed it off, and then me collide. I don't know. Oh. How big is it? 20, 30, 50, 50. 50, I will have a collision for sure. And then I will print collision if. This makes sense. I'm just running this test for an increasing radius starting from the center of the image. E. Oh. Collision. Oh, also much easier test. And then a nice X return 0 in the main. Okay, I'm just debugging the collision. Okay. This was still running. Okay. Okay, 0, free until 15, and then from 15 on I start getting a collision. So I might expect that this one works. No? Make sense? Or if I want to be a buster, remember what happens to the grid when I do the grid. I could simply paint dark in the grid, mark the sets, but then I would interfere with the collision itself. Because I'm making it dark, and so clearly later on I'm gonna find it dirty. Okay? Okay, we have the collide function. Was painful, but we do have it. I was supposed to talk about inheritance, but yeah, very quickly. Are you up, or do you want, are you baked? Fine? Okay, word struct word item. A word item lives in the word. What word item? What are the members of a word item? Oh. The members of the word item are for sure a pose, which is the position where the word item is located. Does it make sense? Hmm? Pose 2D, thank you. And the overwrite pose. What else do I need? Well, an object can be on another object, right? So a word item can sit on top of another word item. No? Because if I move the base word item, also the upper one will be moved. Clear? What else might have a word item? A radius. It might have a word, the word where it lives in, right? Or star. It's a pointer. Otherwise, you store the word inside. Huh? Okay? Huh? I'm doing the struct of the word item. Then we will manage it later. Now I'm defining the word item. Then we will put something like that in the word. Okay? Then let's think about the constructors. A word item is either put in the word or is put on another word item. If a word item is put on top of a word item, then it asks to the word item where it's put on, which one is the word of the word item where it's put on. Make sense? Or we could recursively ask back in the chain who is the word of an item. We need a couple of constructors. Oh. If we call this constructor parent is equal to 0 and word is equal to W and pose is equal to P. Without too much effort. In the other case, I want to slaughter this bird. In the other case, the parent is equal to P, the word is equal to W parent, W to P parent word. And the pose is equal to P. Does it make sense? Yes? If I initialize a word item with a word, pose to the we're there? Okay, I say, okay, I could initialize a word item in two ways. Either I put it directly in the word, or I put it on the top of another word item. If I put it on the top of the other word item, I assume that this other object is already in the word, and I get myself the word from him, from the parent.
If it's in the pose of another word item, the pose wouldn't be the same.
The pose you impose it, right? No, because the poses are always relative to the reference frame. So if I have this I have a table, like a floor, this pedana here, the table, and the microphone. I have a transform of the pedana with respect to the room. The transform of on the pedana I describe where this object here is, on the table I describe where this is, and so on. So to calculate the position of this object, I will have to multiply this transform by this transform, by this transform, by this transform. That clear? Hence, we do a function that we call posing word. Right? Makes sense. That a word item will ask to the parent, if the parent is null, the position in the word is pose. Otherwise, its position in the word is equal to the position of the word in the word of the parent multiplied by its own position. Isn't it elegant? And this way you can put objects in the word. No matter how many you stack together, remember that we define the operators, the multiplication operator by poses. So we sorted it out.
It's supposed to be.
Huh? Yes! I'm tempted to do one thing.
Shouldn't you?
You know what I'm doing, right? I deleted all occurrences of 2D. See if it compiles. It should, because it was a cancel that I was carrying on. Like, okay, we have the word with word items, right? But the word item is a simple thing. I mean, now let's extend it, and then do you resist 5 more minutes? Or 10, maybe? No. Okay. 4, 7. Virtual void show. And show and basta. Or display, era show, display, draw, mi piace draw. Equals to 0. Virtual void evolve timer tick, time tick. I can also give you float dt, the delta time, equals to 0. Now I have created the base class for all objects that will live in my simulator. Okay? Then in my simulator, it's very possible that I will call it draw for an im show. I will not im show anything. Like what I expect is that into this OpenCV matrix, all objects will be drawn. Okay? And then I will do one single call to OpenCV, passing it the matrix, and displaying this matrix which will be the image where all objects have been drawn. But clearly, your colleague says, but don't you need the word item vector somewhere? I do. Yes? And where do I put the word item? You see that the source starts to become really messy, right? We need to polish it. I promise you that I will stop as I created the vector. Okay? Just let me create the vector. Okay? Let me create the vector, and then struct word item. Now there's a problem that in the word I would like to put a word item, but the struct word is never defined anywhere. So I have to tell the compiler, hey, dear compiler, whenever you will encounter the word item, know that it is a struct. You don't know how it is. So I won't be able to declare objects of type word item, but from this point on, I will be able to declare pointers to object to word item. Why pointers? Because the pointers, they all have the same memory footprint. Okay? So I go back to the vector tuple world star items int num items, right, equals to 0 equals let's be an animal. Yes, they are just pointers. Static vector without mercy. Hundred things. Okay, just to make it simple. Then we will play with data structures. This is a way of declaring a compile time constant in C++. All right. And in the constructor, like, come on, we need a constructor of the word, don't we? Yes. Well, at least I declared an array, right? And I want to polish this array, to set it to null. It's personal matter. Just a mem set, or for int that goes from 0 to blah, 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 blah. No? Wipe it. Or you want to be nice, you can write cz of world item star times max items. Huh? Better. This is polished, polished, polished. I'm losing. I need to start. Now, when the program becomes like that, this is the time that you say, okay, now I need multiple files. Then normally, in this stage of the refactoring, I start splitting the C++, the header, and the C++, and start dividing them into files. Okay? We will continue next time. I mean, I hope you like this sort of experiment. And then next time we will continue, and we will have what you see now. Okay? Ciao.